Typedef is a keyword in the C and C++ programming languages. The purpose of Typedef is to form complex types from more basic machine types and assign simpler names to such combinations. They are most often used when a standard declaration is cumbersome, potentially confusing, or likely to vary from one implementation to another. Under C convention, types declared with Typedef end with T. Such type names are reserved by POSIX for future extensions and should generally be avoided for user-defined types. Usage examples, indicating what a variable represents. A Typedef can be used to indicate how a variable represents something, for example, units of measurement or counts. This code sample uses no Typedefs. This code sample does use Typedefs. Both sections of code do the same thing. However, the use of Typedef in the second example makes it clear that the two variables, while represented by the same data type, represent different and incompatible things. The declaration in congratulate of your score indicates to the programmer that current speed should not be passed as an argument. This would not be as apparent if both were declared as ints. However, note that the indication is for the programmer only. The C++ compiler considers both variables to be ints and will not give any type mismatch warnings or errors for the wrong argument type for congratulate, points your score, in the code snippet below. Although the compiler considers km/h to be equivalent to int in the above code, the two cannot be used interchangeably when the type is changed via a prefix of unsigned, signed, or long. Simplifying a declaration, a Typedef can be used to simplify the declaration for a compound type or pointer type. For example, here a struct my struct data type has been defined. To declare a variable of this type and C, the struct keyword is required. A Typedef can be used to eliminate the need for the struct keyword in C. For example, with. We can now create a variable of this type with. Note that the structure definition and type can instead be combined into a single statement. Or simply we can also use it as. In C++, in contrast to C, the struct, class, and enum keywords are optional in variable declarations that are separate from the definitions, as long as there is no ambiguity to another identifier. As such, my struct can be used wherever new type can be used. However, the reverse is not true. For instance, the constructor methods for my struct cannot be named new type. A notorious example where even C++ would need the struct keyword is POSIX stat system call that uses a struct of the same name in its arguments. Here both C as well as C++ need the struct keyword in the parameter declaration. Using Typedef with pointers, Typedefs can also simplify declarations for pointer types. Consider this. Using Typedef, the above code can be rewritten like this. In C, one can declare multiple variables of the same type in a single statement, even mixing pointer and non-pointers. However, one would need to prefix an asterisk to each variable to designate it as a pointer. In the following, a programmer might assume that errptr was indeed a node, but a typographical error means that errptr is a node. This can lead to subtle syntax errors. By defining a node type, it is assured that all the variables will be pointer types. Using Typedef with function pointers are somewhat different than all other types because the syntax does not follow the pattern Typedef old type name new alias. Instead, the new alias for the type appears in the middle between the return type and the argument types. Consider the following code, which does not use a Typedef. This code can be rewritten with a Typedef as follows. Here, mathfunc is the new alias for the type. A mathfunc is a pointer to a function that returns an integer and takes as arguments a float followed by an integer. When a function returns a function pointer, it can be even more confusing without Typedef. The following is function prototype of signal, 3, from FreeBSD. The function declaration above is cryptic as it does not clearly show what does the function accept as arguments, and what type does it return. A novice programmer may even assume that the function accepts a single int as its argument and returns nothing, but in reality it also needs a function pointer and returns another function pointer. It can be written more cleanly. Using Typedef with typecasts, a Typedef is created using type declarations syntax but can be used as if it were created using typecast syntax. For instance, in each line after the first line of funcptr is used on the left-hand side to declare a variable and is used on the right-hand side to cast a value. Thus, Typedefs can be used by programmers who do not wish to figure out how to convert declarations syntax to typecast syntax. Note that, without the Typedef, it is generally not possible to use declaration syntax and cast syntax interchangeably. For example, usage concerns. Some people are opposed to the extensive use of Typedefs. Most arguments center on the idea that Typedefs simply hide the actual data type of a variable. For example, Greg Kroch-Hartman, a Linux kernel hacker and documenter, discourages their use for anything except function prototype declarations. He argues that this practice not only unnecessarily obfuscates code, it can also cause programmers to accidentally misuse large structures thinking them to be simple types. Others argue that the use of Typedefs can make code easier to maintain. Kander states that there are two reasons for using a Typedef. First, it provides a means to make a program more portable. Instead of having to change a type everywhere it appears throughout the program's source files, only a single Typedef statement needs to be changed. Second, a Typedef can make a complex declaration easier to understand. Usage in C++. In C++ type names can be very complicated and Typedef provides a mechanism to assign a simple name to the type. Consider and. Use with templates. There is no direct way to have templated Typedefs in C++ 03. For instance, to have string pair t, represent std pair std string, t, for every type t one cannot use. However, if one is willing to accept string pair t, foo in lieu of string pair t, then it is possible to achieve the desired result via a Typedef within an otherwise unused templated class or struct. In C++ 11, templated Typedefs are added with the following syntax, which requires the using keyword rather than the Typedef keyword. Other languages, in many statically typed functional languages, like Haskell, Miranda, OCaml, etc., one can define type synonyms, which are the same as Typedefs in C. An example in Haskell. Type pair of ints equals. This example has defined a type synonym pair of ints which means the same as a pair of ints. In Seed 7 the definition of a constant type is used to introduce a synonym for a type. Const type, my vector is array integer. In Swift, Typedef is called type alias. Type alias pair of ints equals. C also contains a feature which is similar to the Typedef of C. See also, abstract data type, C syntax, references.